So when we eat sugar, we actually release certain hormones like insulin. Everybody say insulin. Insulin's a pro-inflammatory hormone, and it's also a fat storage hormone. So it increases inflammation in our body, and it also increases fat storage. We also release dopamine and serotonin, and that makes us feel really, really good, okay? So we feel good when we eat sugar. How many of you guys have had that sugar high before, right? You feel amazing. Unfortunately, it's short-lived, because then we have a blood sugar crash, we have hypoglycemia where our sugar goes low, and then of course we get hungry, we have cravings, and we're driven by the need to eat. And so we kind of have this continual process, and really sugar is the number one addiction in our society. Would you guys agree? Right? When it comes to a substance, sugar is absolutely a number one addiction, and it's a chemical poison in our system. And what we know with cancer cells is that there are distinct differences between cancer cells and normal cells. One of the big differences is that cancer cells are glycolytic, meaning that normal cells are very good at utilizing fat or ketones for fuel when we have enough oxygen, right? Like you guys are all sitting there, you're not out of breath, you've got plenty of oxygen, you can use fat for fuel. Cancer cells, even when there's plenty of oxygen, they won't use fat for fuel. They're obligate, this is the term, they're obligate glucose metabolizers, meaning that they basically are just going to metabolize glucose and use that for fuel, and they can also use an amino acid called glutamine, okay? So this is kind of how it works. So we've got this normal cell, all right? And you guys could see that little organelle within the cell. It says TCA, OXPHOS, everybody see that? That's called the mitochondria. Everybody say mitochondria. That's where we produce all the energy within every single cell. Right? Mitochondria is arguably, although all the organelles are important, arguably the most important organelle within the cell. And so the cytoplasm, which is basically outside of the mitochondria, everything in the cell outside of the mitochondria, that's where we can utilize glucose for fuel. And this is a great pathway to produce energy, because when we need very, very quick energy, our body doesn't have enough oxygen. Like, for example, when you're exercising at a really high intensity, you don't have enough oxygen to produce the energy you need. So the body can use glucose, turn it into ATP, and ATP is cellular energy. And as a byproduct, it produces something called lactic acid. How many of you guys have ever felt the burn of lactic acid before? Raise your hand, right? So lactic acidosis in a muscle will cause a burn. That's that burning sensation. Now, in short amounts, right, for short periods of time, lactic acid has amazing health benefits. But when we're chronically producing a lot of lactic acid, we end up with a metabolic acidosis. How many of you guys have heard somebody say, cancer thrives in an acidic environment? Raise your hand if you've heard that. Well, here's the thing that you probably didn't hear. Cancer actually creates the acidic environment. It's not really necessarily like, oh, this food here is acidic, this food is alkaline. That's not really how it works, okay? It's really more about what's happening on a metabolic process. If we're producing a lot of this lactic acid, not clearing it, then we are creating a state of metabolic acidosis, and that actually is where cancer does thrive. It actually weakens the immune system and scrambles the immune system so it can't see where cancer cells are developing. And so when we look at cancer cells, we know that they have 10 to 50 times more insulin receptors than normal cells, meaning that cancer cells are just very, very selfish cells. And their whole focus is trying to drive as much of the nutrients they need out of the bloodstream to themselves. They're self-serving. Whereas all the other cells of the body will give up their lives for the good of the whole. Kind of like a great community or a great army. It's like, a brotherhood or a sisterhood where we're going to all sacrifice for the good of the whole. Cancer cells don't think like that. They're 100% selfish. They will take down the whole organism in order to feed themselves. And so they upregulate these insulin receptors, and they're constantly sputtering out lactic acid and creating energy through glycolytic pathways. And so here's a study right here, 2016 study, cancer-generated lactic acid, okay, and they're talking about, hey, if we can block the lactic acid production, then that may have a beneficial effect on cancer. But you know what? one way that we can help reduce that lactic acid production is reducing the amount of sugar that we're consuming, carbohydrates that we're consuming. Because here's 10 ways that sugar impacts cancer. So number one is cancer cells will actually take glucose and they produce an antioxidant within themselves called glutathione. Raise your hand if you've heard of glutathione. Okay, it's the master antioxidant within our cells. It helps regenerate all the other antioxidants. And so cancer cells produce this as well, and they can actually take glucose. So the more glucose in the bloodstream, the more continuous feeding of glucose that cancer cells have, the more glutathione they can produce to protect themselves. It also stimulates insulin-like growth factor, right? And so if you've ever read like the China study, for example, they talked a lot about IGF-1. The most potent stimulator of IGF-1 is actually sugar, carbohydrate in the diet. It also stimulates mitosis, and that's cell reproduction. All right, and so we need to control cell reproduction. One thing we know about cancer cells is they're reproducing very, very quickly, and that's why they end up growing. It's how we end up developing tumors. Okay, it's these very, very fast-growing and fast reproducing cells. So we know sugar increases that. There's a hormone called leptin. Raise your hand if you've heard of leptin. Leptin is a hormone that helps us be satiated. So when we have good leptin sensitivity, we don't have as much hunger or cravings. Okay? When we don't have very good leptin sensitivity, we have more cravings. Now, just like insulin, we want leptin levels where we want our body to produce leptin, but only in a certain amount, a small amount, and our brain to be sensitive to it. Leptin's produced in our fat cells, travels up to our hypothalamus in our brain, which is like an antenna, and it tells the brain, okay, I'm satiated, let's burn fat for fuel. Okay, when we produce a lot of leptin, just like insulin, it ends up creating a state of leptin insensitivity or desensitizes the leptin receptors, and that elevated amount of leptin will actually also stimulate cell migration, right? Metastasis. So we also know that sugar drives an increase in DNA damage. So it drives up a lot of oxidative stress. Raise your hand if you've heard of that term, oxidative stress. So oxidative stress happens with every function in metabolism. But again, we need to keep this under control. When we're consuming sugar, we're producing a lot, excessive amounts of oxidative stress, and that damages our DNA, particularly the security guard in our DNA called the P53 gene. If you're taking notes, write that down. P53 gene is actually what protects the cell. And so when it sees an abnormal copy or a copy of the cell, like as the cell's reproducing, and it says, you know what, this copy is dysfunctional, right? Maybe it has a dysfunctional mitochondria in it. It will trigger the cell to either repair itself through a process called autophagy or self-eating, or what it will do is trigger something called apoptosis, programmed cell death. So that's what it does. But when we have excessive oxidative stress, we mutate that P53 gene. We can't now keep these cells in check. On top of that, sugar will promote angiogenesis, meaning the growth of new blood supply. Cancer cells want all the nutrients they can get, so they'll actually send out things like something called VEGF, or vasal endothelial growth factor, which basically tells the blood vessel next to it to start sprouting a new branch and bring more blood, driving it right into that cancer cell. We also know that sugar blocks vitamin C uptake by white blood cells, particularly macrophages. And macrophages do something, macro is big, right? So these are big white blood cells that their job is to basically destroy cancer cells, okay, and destroy bacteria and things like that. It actually reduces their ability, it's called the phagocytic index, their ability to eat abnormal cells by 75%. When you have a blood sugar of 120, okay, which is pre-diabetic, so if you have a fasting blood sugar of 120, they would call you pre-diabetic, 126 is diabetic. However, most of you guys in this room don't have a fasting blood sugar of 120, but if, like for example, if I ate like I used to, if I ate a big bowl of, like when I was growing up, my mom would never get the cereals that I liked, which were, Trix and Fruit Loops and everything I saw on TV. Instead, she'd get Cheerios, because Cheerios is healthy, right? And then we put skim milk because, of course, or soy milk or something because we didn't want the fat. And then we put banana on there because, you know, bananas are fruit. They're healthy for us, and they're sheep, right? So we'll put the banana on there. And then maybe on a special occasion, we'll drink some orange juice because that's got a lot of vitamin C. The problem is when we consume that sort of all-American breakfast, what does all of that have in it? Sugar, right? So my blood sugar would go through the roof. I'm sure it was way over 120. It was probably up in the 200s, if not more. And probably for like a good hour, it would be in that place. So my phagocytic index would drop completely, making me more susceptible to getting colds, fevers, flus. Then I would have reactive hypoglycemia because, of course, my blood sugar would drop really low. And 2 hours later, I was falling asleep in my English class, right? And so this is kind of what typically happens in our society. So we need to make sure our immune system is really strong. Sugar, we know, damages that. It also increases interleukin-6, and that's what we call a cytokine, which is basically an immune messenger that triggers an inflammatory process. Raise your hand if you've heard of inflammation, right? So IL-6 helps activate inflammatory pathways in the body. And so it would basically, inflammation is kind of a great environment for cancer to grow. We have chronic inflammation. That just fuels the flame for cancer. It's like pouring gasoline on a fire. It drives up circulating estrogen levels. We know when we have higher insulin is accompanied by higher estrogen. So for women, that oftentimes can lead to things like endometriosis, menstrual issues, breast cancer, right? All different types of issues. So female reproductive types of cancers. For men, higher levels of estrogen can lead to obviously low testosterone, and things like prostate cancer, colon cancer are linked with that. And then on top of that, it stops, when we have high insulin, that stops that normal apoptotic process, right? All of our cells know that when they're growing out of control, there's a switch, and that switch kills them, okay? And it's built within them. But when we have high insulin, it blunts that response, and we're not able to do it.